You better watch out. You know,
All right, guys, so I got a bunch of your quizzes graded yesterday and then this morning. They're not all graded yet. I will finish those up today probably and then get those into the grade book. Please make sure you go back into them when you see the grade in the grade book. Even if you did like really well, you want to go back in and see what mistakes you made so that you don't repeat those mistakes on the test that we're going to have next week. Okay? So just to kind of let you guys know, we have 2 more topics in stoichiometry, and basically we're going to deal with the first topic today. It's called solutions, dealing with molarity, which if you remember back from Unit 5, we talked about molarity then. And then tomorrow we'll talk about gases. And so there's nothing like too crazy, like new or different here. It's just another way to kind of apply our stoichiometry knowledge to a different situation. Okay, so let's go ahead and open up our assignment. We're going to do a couple problems on this together as example problems. We do have a little bit of notes at the top of the page here, but not too much. So let's take a look at this. All right, when I say that word solution, I hope you remember, maybe, I don't know, back from Unit 4, actually, we learned that word. A solution is a homogeneous mixture. All right, so what that essentially means, right, if you want to break that down, bless you, a little bit further, is that we've taken a solid, some sort of solid, we've dissolved it in some sort of liquid, like usually water, all right, and we can't really tell that that thing has been dissolved in that liquid, right? So it's like when you take salt and dissolve that into water. If you only put a little bit of salt in, you're going to be able to dissolve all of that salt. So you'll have salt water, but you won't be able to see those 2 components separating out. Okay, and that's what we mean by a homogeneous mixture. All right, so I already spoiled this surprise. The unit typically given when discussing solutions is molarity. All right, and hopefully when you see this equation again, you'll remember this. Molarity is capital M, and it equals moles over liters. All right. Is that ringing any bells? Yeah, maybe. All right, so we want to rearrange this equation. We'll rearrange it in the only 2 ways that it could be rearranged, just so you have those equations at the top of your worksheet here for your reference, right, later on in the day. All right, so if I wanted to get moles by itself, I'm going to come down here and rewrite it just so I don't screw that one up. So I'll put a little box around this one because this is an equation we will use. So if I have molarity equals moles over liters, if I wanted to get moles by itself, I multiply both sides by liters, so that I can get liters out of the denominator there. And then what we come to see is that moles equals molarity times liters. All right, everybody follow my algebra there? Little algebra for you this morning. Get you prepped for your algebra keystone. All right, just kidding, not really, but so there you go. Now, if I wanted to find liters, how would I do that? So let's come over here. I'm going to rewrite the equation just so we have space. So we're actually going to start it the same way. We're going to multiply both sides by liters because we got to get liters out of the denominator. All right, so they go away. And then I have liters times molarity equals moles. So then I have to divide both sides by molarity, both sides by molarity. And then I come up with liters equals moles over molarity. Absolutely. Let me get everything on the screen. How about that? Sounds good? Yeah. All right. Now, please don't sit there and sweat if you're like, algebra is hard. I don't know how to do that. or that makes me nervous, you're not going to have to rearrange these equations on your own. We just did them all, and now these are your reference like equations, right? Think back to like physics. You guys used a lot of equations, right? So these are like the equations that you are going to use in the following problems to solve solution stoichiometry. Okay? I like to show you how I got them because you are all capable of calculating those, right, with your algebra skills. All right, so let's dive into a problem and see what we're going to be dealing with here, okay? We're going to combine molarity, right, solutions, and stoichiometry, all right? Sounds a little scary. Don't be too intimidated. All right, so this problem says determine the mass of lithium hydroxide produced when 50 milliliters of 2.0 molarity lithium nitride reacts with water according to the following reaction. All right, so you know the deal. Let's identify our given and our find first. So we're given 50 milliliters and 2.0 molarity, the lithium nitride, which is the Li3N compound, okay? We're asked to find the mass, so grams of lithium hydroxide, which is the product there, the LiOH. All right, so a couple of different things we're going to have to deal with. First off, molarity doesn't use milliliters, right? Molarity uses liters, so we're going to have to convert that into liters. Easy. We know that there are 1,000 milliliters in a liter, so we can deal with that. And then what I'm thinking is we have molarity, we'll have liters. We can use that to solve for moles of Li3N, okay, using molarity. And then you guys are actually all capable of going from moles of Li3N to grams of LiOH, okay? That's the process that we're about to take. Don't worry, I'm going to show you every step, okay? So you know the drill. Let's go ahead and balance this puppy out. I think we need a 3 here. And that means we'll need a 3 here. And I think 1, 1. So 1, 3, 1, 3. All right. So perhaps up above here, you're going to want to write down the conversion for milliliters to liters. So there are 1,000 milliliters in 1 liter. So if I have 50 milliliters and I want to convert that to liters, I'm going to take 50 milliliters and essentially divide it by 1,000. Okay? If you're comfortable with like just moving decimal places, you're more than welcome to do that. I like to just do the math there and show the conversion. So we end up with 0.050 liters. All right, guys, that's probably the biggest mistake I see with these problems. People forget to convert from milliliters to liters. Okay, so just be on the lookout for that. All right, so let's figure out which one of our equations up here we want to use. We have molarity in liters, so we're needing to be solving for moles. So I'm thinking we're going to use this moles equals molarity times liters, okay? So moles of Li3N is equal to the molarity, which they give us as 2.0, times, how many liters did we just find? 0.050 liters. Okay, we've got 2 sig figs in both of our numbers here. So my moles should come out to be 2 sig figs. I get 0.10 moles Li3N. Well, we have this stoichiometry to do next. Yeah. Yeah. We're almost there. So let's actually kind of like look at this. This is all the new stuff that we are just learning right now. Okay. Anything past this is just going to be stoichiometry now. So if I asked you to go from 0.10 moles of Li3N to grams of LiOH, you would be able to do that, right? You did a problem very similar to that on your quiz yesterday, okay? So let's go ahead and set that up. 0.10 moles of Li3N over 1. All right, I'm going to have moles of Li3N in the denominator, moles of LiOH, because that's what I'm trying to find in the numerator. This is a 3 coefficient, this is a 1 coefficient. And then the last thing that I'm going to need is the grams of LiOH, which is going to be the molar mass, so we can calculate that and plug that value in. All right, lithium is 6.941, plus oxygen is 15.9994, plus hydrogen is 1.00794. That molar mass comes out to be 23.95 grams per mole. So plug that value in the numerator here. And then I am ready to solve this out. All right, keep with your 2 sig figs here. I come out with a value of 7.2 grams of LiOH, bless you, as my final answer. How do we feel?
Pretty good.
Pretty good? I like that. All right, now you probably have already guessed, or maybe you didn't guess, I'm not sure. But you can do limiting reactant with solutions. Oh, I know, it's tough. Do you think you want to see another problem without limiting reactant first before we do a limiting reactant?
No.
Ava says no. No, we're ready to dive right into limiting reactant? All right, all right, all right. Let's do it. Let's do it. I mean, it's all the same, right? It's just a little bit longer of a problem. All right, let's do number 2. Let's do number 2. I'm gonna come down here because you know I'm gonna need more space. Oh, man. Stop it. How do I get a new page?
You have to just draw at the very bottom of the page, and then you move.
What would I do if I use it? Not be able to function. All right, here we go. Determine the mass of nickel 2 hydroxide produced when 0.73 grams of nickel 2 nitrate. Okay, so that's no different than our normal limiting reactant problems, right? So that's pretty good. Reacts with 500 milliliters of 1.5 molar sodium hydroxide. Okay, so that's definitely like the new solution stuff. Sodium nitrate is a product that remains dissolved. All right, so first things first, let's write out this reaction. So we've got nickel 2 nitrate. Oh, so NiNO3 2. And they're saying that that is reacting with sodium hydroxide. So that's NaOH. And then they tell us that sodium nitrate is produced, so NaNO3. And then they tell us that nickel 2 hydroxide is also produced. This to me looks like a double replacement reaction, right? They've switched partners here. All right, so let's balance. And we have 2 here, 2 here, and I think 1, 1, 2, 2, 1, it looks like. All right. So for our BCA table, we are going to need to convert our two amounts given to us here into moles, okay? So the first one is 0.73 grams of nickel 2 nitrate. That's easy. That's not new to us. We know how to convert that. So let's go with it. We're going to take our 0.73 grams of NiNO32 over 1. We're going to have 1 mole NiNO32 on the top. And then we're going to have the grams of the NiNO32 on the bottom. We are going to need to calculate our molar mass. All right. We've got 2 nitrogens there. Once we distribute. And then 6 oxygens. All right, and I get that value to come out to be 182.70. All right, I can plug that in up here in the denominator. And then we're going to divide. I need my calculator. All right, so 0.73 divided by 182.70. Oh boy, we get a tiny number. We'll have to round that to 0.0040 for 2 sig figs. Point 0040. Okay, nothing new so far, guys, right? So that you probably did a step very similar to this on your quiz yesterday. All right, so we can plug that value into our BCA table. Okay. Now, with my sodium hydroxide, they give us 500 milliliters of 1.5 molar sodium hydroxide. So we are going to have to do a little bit of manipulation here. We're going to take our 500 milliliters first, and let's convert that into liters because I can't use milliliters with molarity. Okay. When I divide that, I get 0.500. Notice that I'm using 3 sig figs here because sugar. 500. Oh no, they have a decimal point here, guys. That's why. Sneaky. That's why I have 3 sig figs there. All right. Hate when they do that. All right, so now I've got my liters. Now, what's our equation going to be? Moles equals molarity times liters. So let's go ahead and let's plug this in. So our molarity, they give that to us, 1.5 capital M for molarity times our liters that we just calculated. All right, now we're going to cut down the 2 sig figs because 1.5 has only 2 sig figs. Okay, so when I multiply that out, I get 0.75 moles of LiOH. All right, is everybody comfortable using this little equation here? John?
What did you get for the very first?
I got, what final answer did I get?
Yeah, what you?
Oh, unit, I got 0.0040 moles of NiNO32, the nickel 2 nitrate. All right, so 0.75 moles of LiOH, that's going to go in my BCA table under the NaOH. Is that right? Yeah, that's right. All right, so 0.75. All right, you know the drill. We only start or we never start with any product, so we have 0 and 0 there. All right, so what do they actually want us to find? They want us to find the mass of the nickel 2 hydroxide. So what that tells me about my sodium nitrate is that I get to squiggle him out. We're not worried about him. All right, so let's figure out our limiting reactant. I'm going to start this right now for the rest of the problem is there's nothing new, right? This is just a straight up limiting reactant. You have moles of both of your reactants now. You're looking for the grams of NiOH2 and your limiting reactant essentially, okay? So the only new stuff was what we did right here. All right, so let's do it to it. So we need to figure out our limiting reactant. I'm going to start with my 0.0040 moles of my NiNO32 over 1. So let's see, we have 2 moles of NaOH coefficient and balanced chemical reaction, and we have 1 mole of NiNO32. All right, so 0.0040 times 2 gives us 0.008. Are we down to 2 sig figs? So 80 moles of NaOH. And here comes your favorite question. Do I have at least this amount? By the way, just a shout out to those people who actually wrote this down in their work yesterday. Made me smile. Yeah, do I have enough? All right, that would be cool too. So do I?
Yes.
Heck yeah, I have plenty, right? Because I've got 0.75 moles of the other thing, so this is going to work. All right, so what that means, and you know the drill, this is our limiting reactant, this is our excess reactant. So we're going to use all of that NiNO32. This is going to be minus 0.0080. This is going to be minus all of it, since it's our limiting reactant. We end up with 0 moles there. 0.75 minus 0.008. Be careful with these small decimals, guys. 0.742, but I should only have 2 sig figs, so it'll come out to be 0.74. All right, so let's go ahead and use our limiting reactant to figure out how much product we're going to produce. Can anybody tell me the change value without calculating it for my NiOH2? John?
Oh, never mind.
Oh, okay, Ava? Yes. Beautiful. So it's going to be plus 0.0040. Guys, I'll prove that to you. Okay? Here's why. All right, I'm going to do a mole-to-mole calculation, but my coefficient for the product is the same as the limiting reactant. So it comes out to be the same value. Okay? If you are not comfortable looking at the coefficients and making those connections, I don't care. It's okay. Okay? You can always just do this calculation. You're going to have plenty of time to do this calculation. Even if you're pretty sure, but you want to verify it, you want to check it, you want to prove it, and there's no shame in that game either. All right, so let's put that in, and then we just need our after for this product, 0.0040. All right, now my last step here, guys, they do want the mass, okay, as per normal. So I'm going to take these moles, and I'm going to go ahead and convert this into grams. So I'm going to need my molar mass to do that. Okay, so I'm going to have my grams of NiOH2 on the top. bottom. Do our molar mass. Nickel is 8.69. We've got 2 oxygens and 2 hydrogens. Oh, sugar. I ran out of space, guys. I'm just going to put that here and show them the hydrogen. All right, that molar mass comes out to be 92.71 grams per mole. So I can go ahead and plug that in the numerator up here. All right, we have 2 sig figs here. So my answer comes out to be 0.37 grams of the NiOH2. Not too bad, right? The new stuff is pretty straightforward, right? There's you use the formula, you plug in molarity, you plug in liters, and then boom, you're done. Not that bad. All right, guys, any questions or concerns here? All right, so let's look at your problems together here. I am going to tell you which ones are limiting reactant and which ones aren't. So number 1 is not limiting reactant. So maybe that's where you should start, just to like give yourself another practice with these. Number 2 we did, but that was a limiting reactant. Number 3, I want to write the reaction out with you, and it is not limiting reactant. But we'll come back to number 3. I want to write that reaction out with you just because the wording in the problem is really strange. Number 4 is limiting reactant. All right, and then number 5 is not limiting reactant. I don't believe number 6 is either, but no, number 6 is not either. So you really only have 1 more limiting reactant there. All right, friends, let's write the reaction out for number 3, and then I will let you guys go and get started on this. All right, so the weird thing about this reaction, and I wouldn't give you something like this on the test, it tells you the reactants are hydrochloric acid, all right, so HCl, aqueous, and silver nitrate, so AgNO3. Ignore the water, it's just there to dissolve everything. It's like kind of weird. I don't know. It's just strange. So then your products are silver chloride and nitric acid, which is HNO3. All right, so you have your reaction there. It's a little strange. All right, so just be careful with that one. All right, guys, any questions or concerns before I let my virtual friends go? Okay. All right, do your best with this. If you get a little lost or confused, just shoot me a message on Canvas. All right, and we will continue with our gases tomorrow then. So look forward to that. Good times. All right, virtual friends, have a good rest of your day, and I will see you guys tomorrow, okay?
Thank you.
You're welcome. Have a good day, honey. What's this? Stop. That's like no. The one is that realistic though? No. If they have certain like what? Yeah. The one time I was introduced and I know there. And it's not yeah. No, it's not everyone.